All right, guys, we are looking at graphing logarithmic functions. There's a couple things we need to know before we can really understand how to graph these. One thing you're going to need to know is you're going to need to understand this conversion. This one right here is in exponential form, and this one right here is in logarithmic form. You're going to need to be basically in this graphing scenarios, it's going to be given to you in log form, and you need to be able to convert it into exponential form. The other background information that you guys need to know is that basically the effects of h and k. You guys should know that k is the thing that happens like after the rest of the equation, and that's the thing that is shifting up and down, and vertical shifts happen the way that you think they would. On the other hand, h is the thing that's going to be inside the parentheses here. H is a horizontal shift, and horizontal shifts happen the opposite way that you think they would. So if you understand both of these two things, I think we're going to be able to understand graphing logs in general. Let's go ahead and take a look at our steps. The first thing you're going to want to do is identify the parent function. When I say identify the parent function, essentially what you are doing is you are getting rid of the h and k. So if you were to get rid of the h and k, let's just pretend here, I'll put it back in a second, you'd have y equals log base b of x. So whatever that b is, like if it's 2 or 3 or 5 or whatever the number happens to be, is going to be very significant. And you're just going to get rid of those h and k. So b is the number that you're keeping. The other thing you're going to need to do is convert it into exponential form. And I will show you that on the next slide when we actually take a look at an example. I do want to point out that graphing logs is not going to be something that we're doing on our calculators, unfortunately. Most of our graphing has exclusively been with our calculators this year. However, graphing logs is a different beast, and so we're going to be relying on doing these by hand. Step 2 says to create an XY table. You guys are good at creating XY tables, right? We've done this for years now, or a T table they're called. What makes this unique is this is the first time that we're ever going to input the y's instead of the x's. Traditionally, you would go here, you'd make your T table, then you'd input things like probably -2, -1, 0, 1, and 2 into the x's, and you plug them in, and then you see what you get out for y. This is going to be weird because we are going to be putting -2, -1, 0, 1, and 2 in for the y's and inputting those in y and solving for x. At this point, you're going to graph. Step 3 says graph this table, get those points. And then step 4, our final step, is you're going to now take the effects of h and k. Remember, step 1 said forget about h and k. You're going to now reintroduce h and k, keeping in mind that h is your horizontal shift, and that happens the opposite way that you think it would, and k is your vertical shift, and that happens the way that you think it would. So let's take a look at an example. The equation we want to graph is y equals log base 3 of x. This one does not have an h and k, so we don't have to forget about them. They don't exist. We're going to start out converting this into exponential form. It's currently in log form. We want it to be in exponential form. The base of the log base b, right, is going to be the same as the base of your exponent. So this is going to be big 3 to a power is equal to, all right, so 3 to what power? Over here, let's take a look at, it's 3 to the thing that's on the opposite side of the equal sign, right? So it's equal to x. That's what actually goes in the exponent. So this is going to say 3 to the y, and then is equal to x. This is going to be weird because generally things are equal to y. But when you do this conversion from log form into exponential form, those get switched. And so we have 3 to the y equals x, and that's actually going to be the reason why we plug these things in for y. Let's say we didn't do that. We plugged them in for x, -2 in for x. You'd put a -2 in here, and you'd be like, hey, what do I take 3 to the power up to get -2, and do carry on. That's more difficult questions. However, if you plug these in for y, I can type 3 to the -2nd power into my calculator, right? Or we should be able to even process that on our own. Negative exponents go down to the denominator, we get 1/9. 3 to the -3rd, or 3 to the -1st is 1/3. 3 to the 0th power is 1, 3, and 9. So at this point, we would graph these and be really mindful that, remember, we've switched our x's and y's, so we have to graph these. Like, you have to just be careful. 1/9 is barely over 1. -2 would be right about there. 1/3, -1. 1, 0, 3, 1, and 9, 2. This is actually going to have an asymptote here at 0. It's never going to get below 0. It's just going to approach it forever. We're going to get this equation. As you should expect by now, when we graph, we have to come up with the domain and range. The domain of this function is asking what x values does this graph exist on? Well, this graph never achieves any of these negative x values. It's approaching 0 forever on the x. So that's actually going to be its starting point, and it's going to get a soft bracket because we do not want to include 0. This graph will not actually achieve 0. So starting at 0, and then what x value does it go till? Well, it's going this direction forever, right? It's going to infinity there, so the domain would be 0 to infinity. The range is asking what y values does this graph exist at? This graph goes down forever, over here, right? And it goes up forever. It's growing slowly, but it still is going up forever. And so the range here is going to be all reals. This is going to be different than what we're used to. We've seen lots of graphs that have all reals in the domain and then a restricted range, but this graph, because of kind of the way that we did the x's and the y's and things like that, the behavior of it is going to be opposite in a lot of ways. Let's look at another example, y equals log base 2 of x. We should be able to do this conversion by now. This would be 2 to the y power is equal to x. Make your t-chart, plug in the values in for y. We should be able to fill this in. 2 to the negative second power is 1/4. 2 to the negative first power is 1/2. You should be able to get all these from your calculator if you don't know how to do them by hand. 2 to the 0th power, anything to the 0th power is 1. 2 to the first is 2, and 2 to the second is 4. Now we should be able to go ahead and plot these points. 1/4, -2, that'd be like right there. 1/2, -1. 1, 0. 2, 1. 4, 2. I could actually get another point. If I plugged in 3 here for y, I would get 8, 8, 3. Just helps me be accurate there with that extra point. So this graph right here is y equals log base 2 of x. Now, let's say hypothetically, that didn't work. Let's say hypothetically that this was my graph. Okay? Y equals log base 2 of x plus 3 minus 2. So remember our steps. We said ignore h and k. So you forget about this stuff. And you would graph y equals log base 2 of x, which we just did. And then you reintroduce these transformations at the very end. So we should know that -2 shifts everything down 2. And a +3, I would think +3, if I knew it was horizontal, I would think that that would shift to the right 3. But because horizontal shifts always happen the opposite way, that's actually going to shift to the left 3. So what I should be able to do is I should be able to take all those points that I plotted and move them down 2, 1, 2, over 3, 1, 2, 3. Do the same here. Down 2, 1, 2, over 3, 1, 2, 3. Down 2, 1, 2, over 3, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Then we get the new translated graph. So how does that affect our domain and range? Remember, domain is asking what x values does this graph achieve? Well, no x values out here are achieved, but now our graph is starting at -3. So it's going to start at -3 and then go to the right forever. So its new domain is -3 to infinity. Once again, both soft brackets. Essentially, we took the old domain and we shifted it to left 3. The range, this graph is still going down forever and still going up forever. So the range is all reals, or if you wanted to do negative infinity to infinity. That's supposed to be an infinity. That's really ugly. I'm sorry. Let's do one more. I just want to do one with a fractional base. It's not really that different. We should be able to do the conversion. We're going to have 1/4 to the y power is equal to x. We should be able to plug in -2, -1, 0, 1, and 2. And for y, 1/4 to the -2nd power would be 16. 1/4 to the -4th to the -1st would be 4. 1/4 to the 0 would be 1. Anything to the 0 is 1. 1/4, 1/16. So we're going to graph this much the same. 16, -2, that's way out here somewhere. I don't like it that much. 4, -1, 1, 0, 1/4, 1, 1/16, 2. I can go ahead and plot this. Domain restricted once again. No x values are ever being achieved out here. It starts at 0 and goes forever. The range, on the other hand, is once again all the ranges. If you haven't picked up on this, it goes down forever. This is going down just very slowly, and up forever. So the range would be all reals. Let me know if you guys have any questions. Be sure to stop into my office hours if you do.